Problem number 6, we see g is defined as this piecewise defined function. It's the parabola when x does not equal 2, and it's m when x equals 2. So, what value of m will make this continuous? So to draw a quick picture of what's going on here, we've got a parabola. I don't know exactly what it looks like. We don't need to pull it up on our graphing calculator. But let's just say it's doing something like this. As long as x is not 2, we have this parabola. All right. When x is 2, we are going to be m units up or down. And the question is, how far up or down are we so that we can fill in this gap right here and therefore have a nice continuous function? Well, in order to figure this out, we just need to figure out where the top function is heading as x gets closer and closer to 2. In other words, we have to figure out what the limit as x approaches 2 of the function is going to be. All right, so the limit, remember, doesn't matter what's happening at 2, it matters what's happening as we get closer and closer to 2. These are all the numbers that are closer and closer to 2. So we're going to plug 2 into the top. When we do that, we get negative 4 plus 3 minus 4. Negative 4 plus 3 is negative 1, minus 4 more is negative 5. That value of m will cause our function to be continuous. For part 7, for which values of x, if any, is h not continuous? Well, again, with piecewise defined functions, we have to check out when we change conditions. The first time we change is when x is at negative 1. Before negative 1, we're here. After negative 1, we're there. The second time we change is at 0. For up to 0, we use secant. After 0, we use e. And the third time we change is at x equals 2. Before 2, we use e. After 2, we use this polynomial. So what we're looking at here is what kind of situation is going on. Do we have a situation where when one function leaves off and the other function picks up, we have some kind of gap? Or do we have a situation when one function leaves off, the other function picks up exactly where it left off, and therefore we technically have a nice continuous function? One of these two situations is happening at each of these 3 values. So we got to check them all out. Let's start with negative 1. The cube root of negative 1 is equal to negative 1. Secant of negative 1, you might have to go onto your calculator for. It's some messy decimal, but it's definitely not equal to negative 1. So the limit from the left is not the same as the limit from the right. Therefore, the limit doesn't exist. And if the limit doesn't exist, we've got ourselves a discontinuity. So part of our answer is that x equals negative 1. Let's go to 0. Prior to 0, we use secant. Secant is 0. That's 1 over the cosine of 0. Cosine of 0 is 1, so 1 over 1 is 1. You can verify this on your calculator. Then we have e to the 0, because e is our next function. E to the 0, well, we know any base to 0 is going to be 1. Same answer. So it's one of these situations. Secant drops, e picks up, and at the exact same spot. Therefore, the function is continuous there. That's not going to be part of our answer. Now we go to 2. E squared. Not quite sure what that is, but I know it's a messy decimal. All right, 2.7 blah, 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 blah. 2 squared is going to be a decimal. You know what's not a decimal? The answer to what happens when you plug 2 into x cubed minus 9. 2 cubed minus 9 is negative 1. Negative 1 is not a decimal. The limit from the left and the right do not equal each other. Therefore, the limit doesn't exist. Therefore, we have a discontinuity. Those are our 2 values.